I have set up the main measurements on this question. I have my diameter of 140 here in plan. I have all of my heights. My first height from here to here is 5, then 10 to the base of my Hyperboloid of Revolution. I have come up 60 for this line. The entire height of my Hyperboloid of Revolution is 200. Be careful with that. Your overall height is 215 once you add both of those on. So my height just went literally a millimeter above the page there. That's my overall height. So halfway between here and here was up 100. So that's where my throat circle is going to be. Now, if you look at this diameter 60 and bring it down, it's giving me the base of the fireplace, but it also must be the throat circle as well. Otherwise, I would need an extra circle that will be hidden detail in plan. So that's my throat circle, and it's my base. I've marked off my other heights, my down 20 and down 70, these two lines. They will give me that cut and elevation, but I'll have to have my curve drawn first to see where they're actually going to cut it. So you can see there are lots of cuts on this. There is that cut at an angle and elevation, and there's also this line in plan. So that the cut at an angle and elevation must be giving me this curve in plan, and that horizontal line in plan must represent the vertical opening that they're talking about, because anything that is vertical is going to be an edge view in plan. So this must be an edge view of that vertical opening. Now, because I have a couple of cuts in this, I'm going to draw my curve by putting my hyperbola into a rectangle. I actually prefer drawing it using asymptotes, but if I use my asymptotes, I'm just going to have a lot of curves in plan, and because my hyperbola is cut, we find points on the cut surface by taking horizontal sections, and each one of those horizontal sections is going to give me a circle. So I'm going to end up with a lot of circles in plan, and I don't want to overdo it in that sense. So my hyperbola is going to fit into a rectangle. This is my vertex, and I'm just going to highlight this rectangle that it's going to fit into. And I just need to divide opposite sides into an equal number of parts. I'm gonna go, I think I'll just go this way. So we'll go, 4 should be enough. Okay, so when you're drawing your hyperbola, the divisions that would have gone to your vertex in a parabola still go to your vertex in a hyperbola. So that is these 3 lines. And your divisions that would have gone parallel to the axis are now going to your other vertex. And then for line 1 cuts line 1, 2 cuts line 2, 3 cuts line 3, and 4 cuts line 4. Those are your points on your curve. So we'll do a freehand curve through those points, and we will mirror them about the axis to get the rest of my curve. Okay, so you know how to mirror your points. You're just going to open your compass and move it down along for each of these, and then go in the opposite direction about your horizontal axis. Keep your curve light, because remember it's going to be cut, so I'm going from here through those points and down as far as there on both sides. I'm just going to pause this for a second to twirl around my page and get my curve done. Okay, with my curve done, I can now find where my first cut is. And that's my cut that is going from down 20 to down 70, which I think is this line. I'll just double check. Yes, my down 70 is there. So down 70 to down 20. That's my cut. Now when you cut the curve, just make sure that the freehand curve underneath the cut is heavier than the freehand curve above it. Because you need to identify the elevation in a way that makes sense, the elevation that you're left with. Okay, so even slightly is perfect. Right, we want to get that cut to give us our curve and plan. And every time we're doing something like this, like cutting a hyperboloid of revolution, you just need to remember that every single horizontal section is going to give you a circle. In this case, a semicircle. So we're going to start by getting our points. Now, our first point on the cut, I'll give them some numbers so that we can follow. We'll say this is A and this is B. Always very original with our numbers. So A is here. This is your extreme curve. So that is like your extreme generator in a cone. It's the curve that you're looking at 90 degrees to in plan. So this curve in elevation is going from the base to halfway up, which is your throat, and back out to the top. So there to there is the plan of that entire curve. Same on the other side. So when you project down A, that's A in plan. And this is B in plan. Here's a model of our chimney structure with the cutting plane, simply inclined cutting plane. We see it as an edge in elevation. and it's going to take a slice off our hyperboloid. So we're just going to look at the sections and even just find one of those points on the cut surface in plan. So you can see our throat circle there is the same radius as the little stand that's at the bottom. And the throat circle is just showing up as a horizontal line in elevation just because of the model. So there's my edge view of my cutting plane. And how I modelled it, we'll just go back over that. I just put it in a rectangle and mirrored that curve around. After mirroring it, I revolved the curve 180 degrees to get half of the hyperboloid of revolution. I'll just hide that sketch again. So just before we start cutting that, I want you to be very clear as to what the model looks like. So if I take that cutting plane and take a slice in SolidWorks, we can get it very quickly what our cut surface looks like. It's at an angle to the axis. So it's giving us a curve which is not a semicircle. Any cut perpendicular to the axis would give us a semicircle. So that's the plan of the cut surface, and that's what I'm looking for. We'll just show you with hidden detail where it's going compared to your throat circle. So we'll go back and talk about how we're going to plot it. So you can see clearly with the model how the curves in elevation, the hyperbola in elevation that's giving you the extreme curve is definitely taken at the back. So where the plane is cutting the very back of the chimney, that's giving me my 2 points on the straight line on plan. Now I'm taking a horizontal cutting plane anywhere, and this is what we do repeatedly to get all of the points on the curve. But if I take that horizontal cutting plane and take a slice, the cut surface that I'm going to get is a semicircle because my cutting plane is perpendicular to the axis. And every time you're getting points on a cut hyperboloid of revolution, you're going to end up using the fact that its cross section is circular in order to plot the points. So no matter what height that's at, it's giving me a semicircle, and the only difference will be the radius of that semicircle. Now what I want to find out is what semicircle will have a point that's also on the simply inclined cutting plane. So that horizontal cut is giving me a semicircle, and one point of that semicircle is also on my simply inclined plane. So that's what I'm looking for in order to complete my plan. So if you see there, the point that's on the yellow plane and on the orange plane is the point that we're looking for. So you can see where they intersect. So that's my horizontal section there, that semicircle. There's a point on that semicircle that's on my cut surface. So I want to project that particular point to plan. So we'll project it through the views. We'll see where it is in elevation and project it down. So you see my 2 points at the back, and we label those A and B. You can see how that edge is just slicing through the vertical back of the shape, giving us those 2 points. Now the point in the front that's on my circumference, I'll be able to find him in plan. So that's my semicircle in plan. So I've projected the point that's on my cut surface to elevation. I'm dropping it from elevation down to plan, so it's there on my horizontal plane and projecting it out. That yellow circle is my cut surface in plan, the cut surface that I got with that yellow horizontal cutting plane. So that has to be a point on its circumference. Now I only projected that point because it was also on my simply inclined plane. So you can see it dropped down in 3D. So we just do that for all of our points with different planes. Now we're going to take a series of cuts in order to find our points. So the next one I'm going to find is what's halfway. So I'm going to take, if I were to take a cut here through that point, I'll say he's C, but I might stop indexing after this in case it gets more confusing than anything. So a horizontal cut at that height is going to give me a semicircle of this radius. So I'm going to draw that semicircle in plan. But the only thing on this semicircle that's also part of the cut surface is point C. So if I drop him down, he's going to be on that circle. C. And we basically just do that a few more times. So I'm going to take 2 more between C and B and 2 more between C and A. So I'm just going to number those. That's 1, 2, 3 and 4. Now I know 1 and 2 will give me points on the curved surface on the left hand side, and 3 and 4 will give me points on the curved surface on the right hand side. So I mightn't draw the full circles again, just to keep things easier to visualize. So on cut number 1, my horizontal cut is giving me a semicircle of this size. There's my semicircle. And this is the point where that semicircle is cut. So that's a point on my cut surface. On my edge number 2, I have a semicircle this size. The only part of the cut surface on that semicircle is this point here. And I very cleverly didn't make them long enough. So let's extend. That gives me that point on the curve. Going up 3, semicircle this size. That wasn't 3. That was an extra one. So I'm taking an extra cut, sorry. Call them 2.5. This is 3. The more points you have, the more accurate your curve will be. So it doesn't really matter, but that was the height that I said I was going to do for 3. So there's another point on my cut. And 4, radius, and that's where 4 is cut. Okay, so my curve is going to go through those points. Now I feel like my first cut there's a big different distance between here and B, but there's very little difference in the radius of the two of them, so just keep that curve really flat when you're doing the freehand curve through it, and it should be fine. So my points, 1, 2, and I'm finishing back at B. Oops, sorry, I'm gonna have to do a bit of a walk around here. So again, keeping it fairly flat. You don't want your freehand curve to have points on it. And there is always that problem of losing accuracy when you try to make it a little bit heavier, but we'll go with that. That's my first section done, my cut there. Second section is this vertical line here. I have no idea in plan how far back to come for that vertical line, but what I am told is the height that that cut is happening at in elevation. So in elevation, that height from the base, it's being cut at a height of 60. I'm just going to tick that height there so I'm sure that I haven't that hairy bit of the line. Sorry, it's just going to bug me. Right. That's my up 60. That has to help me somehow find where this line is in plan. And how it will help me is the same thing that helped me get the cut at the top, is a horizontal section through that height that was up 60 will give me a semicircle of this size. I'm just going to extend that semicircle a little bit so I can see him in plan. That semicircle here went as far as here. So that is the first point. This is the plan of that point. So that is one point on my vertical cut. So I'm going to draw a light line through it, and then it's going to be heavy to there and hidden detail where the top is blocking it off. Now that is my plan complete. So I need to find more points on the curve to complete my elevation. Now in order to do that, I'm just going to take random points on my vertical section. So this is where it hits the base, here and here. I might just do some colors. So that's point 1 and that's point 2, and they're on my base circle. So I can take them directly to elevation. That's point 1 and that's point 2. Right, I need more points than that obviously, so I'm just going to go randomly. I'm going to say point 3, 4, 5, and I already have the top. So if I say 3, 4, and 5 are the plan of points that are actually on this curve, then I need to find the heights of them. They'll be somewhere in vertical lines above those, but I need to know where. So what I'm going to do is rotate my Hyperboloid of Revolution until those 3 points are on my extreme curve. And I'm just going to do them in color. So So I have point number 3 is there. If I'm rotating my hyperboloid, and that's where they would be. And if they were on this line in plan, they're going to be on the curve in elevation. So that's 1 point. It's going to draw little vertical lines. My 3 points. Now I know the heights of my points 3, 4, and 5. And all I need to complete my drawing is project these straight up. So 5 is on my top height, 4 is on the next one, 3 is on the next one, and that was 1. So there's 3, 4, and 5. And what did I do? I just took these lines up, and where they hit the curve, I brought them across. Three, 1, and 6. So I actually have a pretty big gap between C and 5 there, so I think I'm going to take one more point. I didn't want to because it's almost going to be on top of a curve that I already have. I just think I might need a little bit more guidance for that, because there's a big gap to fill in 3D. So this is 6. Yeah, he's ended up very close, but he might still help me. That's my last point, 6. Now I only need to plot half of it because I can mirror it across to the other side, and then do a freehand curve to complete. Keep them flat on the top. Don't know if my 6 helped or not, but finally double check, is there anything else you're asked to do? Projections of the sloping top and elevation and plan, projections of the vertical opening, and job done. Now we'll have a look at that vertical cut just to be clear on how we projected our points in 3D. So I'm going to hide the base of the chimney so that we can see the plan a little bit more clearly. And I've gotten rid of all of the construction to do with the vertical cut on top. The circle that I've drawn on my horizontal plane for my plan is the bottom of the Hyperboloid of Revolution. I've just left all of the base of the stand out of it for clarity. Okay, so that was my cut that was up 60. And you can see the horizontal cut in elevation gives me a semicircle of a specific radius in my 3D view. It just disappeared for a second there. When I take that horizontal cut down to plan, it's going to show me the radius of the circle that is in contact with that vertical plane. So that's why I knew my vertical plane was going to be tangential to that circle in plan, and that gave me the line that is an edge view of my vertical cut in plan. So the middle of that circle up 60 is the first point, or the top point on my cut surface. Just that one there. So you can see it projected to plan, where it is on my 3D model. And it's the point that's closest to me on that vertical cutting plane. So there's my vertical cutting plane. It's going to slice off the front of that curve. Because my plane is infinite, when I show you this cut, it's also going to take a slice off the top. But we'll just ignore that. Just focus on the bottom of it. It's slicing off my stand as well. But it's just showing you that the edge view, the line that you're looking at in plan, is an edge view of that cut through the front of the Hyperboloid of Revolution. So going back to plot that, we're going to do the same thing we did with our model for the first cut. We're just going to take one horizontal section and see how the points on that horizontal section get projected around. So the green circle that you see in plan is a circle that I've taken with a horizontal cutting plane through my Hyperboloid of Revolution, and I'm seeing it as a line in elevation. So I want to know what part of that circle is also on the vertical cutting plane. So it's just an edge in elevation. That's my horizontal cutting plane that's giving me my green circle in plan. And I've taken, you can see the back, I've taken the edges of that semicircle down, which give me my radius. Now that green circle in plan gets cut by my vertical cutting plane there. You can see my horizontal line in plan, which represents my cutting plane, and you can see I have 2 points on the cut surface there. So I need to take those 2 points from plan back up to elevation, and they give me 2 points on the curve. So there's my green circle in 3D. And you can see in this view how much of my semicircle is cut off by the vertical plane. So it's specifically those 2 points that I'm looking for. Is my horizontal cutting plane, and it's where the vertical plane intersects it. And those steps we just repeat for extra points on our cut surface.